A parking garage charges $5 for the first hour, $10 for up to 2 hours, and $12 for the entire day. Let G be the dollar cost of parking for T hours. Number 1, complete the table. So we know that if you don't park for any time, then your cost is going to be $0. If we park for a half hour, then that would fall under the category of $5 for the first hour. So that means 1/2 hour would be $5 and 1 hour would be $5. Our next category is $10 for up to 2 hours. So that means 1 3/4 hours would be $10 and 2 hours would be $10. And our last category is $12 for the entire day. So 5 hours would be $12. Number 2, sketch a graph of G for 0 is less than or equal to T, which is less than or equal to 12. So one thing to remember, a hollow circle means not included. A solid circle means included. So first we know that 0 hours is $0. So at the origin, we would put a solid dot. Our next category is $5 for the first hour. So we can go up at 0 hours, go to $5, and draw a hollow dot there, because we are not including this because 0 hours cost $0, not $5. And the $5 goes all the way to 1 hour, and that is included, so that would be a solid dot. And then we would draw the line that connects them, saying that anything after 0 hours up to 1 hour included is $5. The next category was $10 for up to 2 hours. So we're going to go up to $10 and we're going to put a hollow circle. Then we'll go over to 2 hours and we'll put a solid point and we'll draw the line that connects them. And our last category was $12 for the entire day. So we'll go up to $12 and we'll put a hollow point, and then we will draw a line that goes all the way across the rest of the hours. So as you can see, anywhere there's a solid point, that point is included. So 0 hours is $0. Anything more than 0 hours up to and including 1 hour is $5. Then anything over 1 hour up to and including 2 hours is $10. and then anything over 2 hours is $12. Number 3. Is G a function of T? So remember, a function of means our input is after and the output is before. And a function means every input has only one output. So for this to be true, this means every time has only one cost. And that is true. So, yes, every time has only one cost. Number 4, is T a function of G? Again, a function of means cost is the input and time is the output. In order for this to be a function, every cost could have only one time. But we can see the $12 cost has every time above 2 hours. The $10 cost has every time above 1 hour up to and including 2 hours. So this is not a function because each price has more than one time. Is this a graph of a function? Explain your reasoning. For a graph to be a function, it has to pass the vertical line test. And if I look at x equals 2, I can see that I hit right here and I hit right here because these are solid points. And again, if I go down to x equals 6, I come up, I hit a solid point right here. And if I keep going up, I hit another solid point right here. So no, because at x equals 2, y equals 1 and 7, and at x equals 6, y equals 3 and 7. If you have more than one output for each input, it is not a function. Use the graph of function g to answer these questions. Number 1. What are the values of g of 1, g of negative 12, and g of 15? Remember, the number inside parentheses is your input or your x value. The function equals the output or the y value. So if I want to know what g of 1 equals, I go over to x equals 1 and I go up and I see that I hit a solid dot at y equals 4. So g of 1 equals 4. Next we have g of negative 12. I go left until x equals negative 12, and I go down until I hit the line. And I see that I hit the line at about y equals negative 10. Therefore, g of negative 12 equals negative 10. And lastly, we have g of 15. That means we go right until we get to 15 and we go up. At this point, I hit an open circle, which means this is not included. So we would say g of 15, according to this graph, is undefined. It does not have a y value. Number 2. For what x values is g of x equal to negative 6? So now we don't know the x, they're telling us the y. So we need to find out what x equals when y is negative 6. So we go down to y equals negative 6, and we see that we have a solid point at negative 8, and that goes all the way over until approximately negative 1. So we could say x equals negative 8 is included, so we're going to use a bracket and say 8, and then a comma, or negative 8, I'm sorry, and then negative 1 and a parenthesis because we are not including negative 1. Or you could write it as negative 8 is less than or equal to x, which is less than negative 1. Either method is a proper way to write these values. Number 3. Complete the rule for g of x so that the graph represents it. So our first blank is where g of x equals something when x is between negative 10 included and negative 8 not included. So this is talking about this line segment right here that I'm circling in red. And at that, our y value is -8. Next, we're saying the function equals -6 when x is between blank and -1. That's the section that we had just talked about previously. So that is -8 included, -1 not included. You can see this matches what we found in part 2. Next, the function equals blank when x is between -1 included and 1 not included. That would be this segment up here when y is equal to 2. G of x equals 4 between blank included and blank not included. That's the next line segment. And we can see the solid point at 1 and the hollow point at 10. So this is how we use graphs of piecewise functions to answer questions about it. This graph represents Andre's distance from his bicycle as he walks in a park. Number 1. For which intervals of time is the value of the function decreasing? You have to remember that the value of the function is the y value. So we are looking for what intervals of time the y value is decreasing. We can see between 9 until 11, it decreases down this slope right here. So 9 to 11 seconds. Then we can see again from about 14.5 until the bottom down here at 17 seconds. We can see that it decreases along this slope. And then we can see from about 21 seconds until it hits the bottom down here at 27 seconds. We can see that it decreases down this slope. Number 2. For which intervals is it increasing? Well, we can see from the beginning point at about 0.5 until the point at 9 seconds. We can see that the y value increases. Then we can see from the point at about 17 seconds to the point at about 21 seconds, this slope is increasing. And number 3, describe what Andre is doing during the time when the value is increasing. Well, we know that our y is distance in feet from his bicycle. So if that distance is increasing, then he is walking away from his bicycle. The temperature was recorded at several times during the day. Function T gives the temperature in degrees Fahrenheit, n hours since midnight. Here is a graph for this function. Number 1. Describe the overall trend of temperature throughout the day. In this graph, we would start at midnight. So we can see that from midnight until about 6 a.m., the temperature decreases. Then we can see that from 6 a.m. until about 5 p.m., the temperature increases. And then finally, from about 5 p.m. until midnight, the temperature decreases again. Number 2, based on the graph, did the temperature change more quickly between 10 a.m. and noon or between 8 p.m. and 10 p.m.? Explain how you know. Well, from 10 a.m., this point right here, to noon, this point right here, we see an increase of about 10 degrees in 2 hours. So that's 10 degrees divided by 2 hours. So that's 5 degrees per hour. From 8 p.m. until 10 p.m., we see the decrease of about 12 degrees. And that is over 2 hours again. So this would be an average rate of change of -6 degrees per hour. That means it changed quicker between 8 p.m. and 10 p.m. because it changed 6 degrees per hour as opposed to 5 degrees per hour. And the last question for lesson 12. Explain why this graph does not represent a function. Remember, we have the vertical line test. So if I draw a vertical line right here, I hit this graph in 2 points. If I draw a vertical line here, I also hit this graph in 2 points. So this does not represent a function because multiple x values have more than one y value. And a function has only one y value for each x value. So now we start with the practice problems for lesson 13. This lesson begins to look at absolute value functions. A group of 10 friends played a number guessing game. They were asked to pick a number between 1 and 20. The person closest to the target number wins. The 10 people made these guesses. Number 1. The actual number was 14. Complete the table with the absolute guessing error. The absolute guessing error is how far away the guess is from the actual number. And we don't care whether that difference is lower or higher. So we don't have to worry about positive or negative. Our answer will be the positive number of how far away the guess is from the actual number. So 2 is 12 away from 14. 15 is 1 away from 14. 10 is 4 away from 14. 8 is 6 away from 14. 12 is 2 away from 14. 19 is 5 away from 14. 20 is 6 away from 14. 5 is 9 away from 14. 7 is 7 away from 14. And 9 is 5 away from 14. Number 2. Graph the guesses and absolute guessing errors. So the top row is our x coordinate, the bottom row is our y coordinate. So we have 2, 12, 1, or 15, 1, 10, 4, we have 8, 6, 12, 2, 19, 5, 20, 6, 5, 9, 7, 7, and 9, 5. So this is what the graph of the guess errors looks like. Number 3. Is the absolute guessing error a function of the guess? Explain how you know. And the answer is yes. Every every x value has only one y value. Bags of walnuts from a food producer are advertised to weigh 500 grams each. In a certain batch of 20 bags, most bags have an absolute error of less than 4 grams. Could this scatter plot represent those 20 bags and their absolute errors? Explain your reasoning. So, if they're advertised to weigh 500 grams each, and we're looking at an absolute error of less than 4 grams, that means we would need to be within 496 and 504 with most of our bags. But it looks like we have at least 1, 2, 3, 4, 5, 6, 7, 8 that are outside of it. And maybe 1, 2, 3, 4, 5, 6 that are inside. So it looks like there are more above and below that 4 grams on either side of the 500. So for this one, no, because most points are more than 4 grams above or below 500. The class guessed how many objects were placed in a mason jar. The graph displays the class results with an actual number of 47. Suppose a mistake was made and the actual number is 45. Explain how the graph would change given the new actual number. Anytime we are graphing absolute value functions, we will always get this V shape. Because we're going to have an actual number right in the middle, and then the guesses below and above the actual number will be the same positive distance away. So now, if we change this and say instead of 47, the actual number is 45, this V shape just shifts to the left 2 spots. Now we would have a V shape two spots to the left, centered at 45 instead of 47. But anytime we graph an absolute value function, we will always end up with a V shape, centered at the actual number. Function D gives the height of a drone t seconds after it lifts off. Sketch a possible graph for this function given that d of 3 equals 4. So we said the function gives height, and we're using seconds as our input. We need d of 3 to equal 4. So we go over to 3, we go up to 4, and we put our first point. Now we need d of 10 to equal 0. So we're going to go over to 10, and we're going to put a point at y equals 0. And we need d of 5 to be greater than d of 3. So if d of 3 was 4, I could just say d of 5 is 5. Since this is a drone that is going to lift off, go a little bit higher, and then come back down and land, our graph could look something like this. D of 3 equals 4. D of 10 equals 0. And d of 5 is greater than d of 3 because d of 5 equals 5 and d of 3 only equals 4. The population of a city grew from 23,000 in 2010 to 25,000 in 2015. What was the average rate of change during this time interval? Well, we went from 23,000 to 25,000. That is an increase of 2,000 people. And we went from 2010 to 2015. That is an increase of 5 years. 2,000 divided by 5 equals 400 people per year. Number 2, what does the average rate of change tell us about the population growth? The average rate of change tells us the population grew an average of 400 people per year. Here is the graph of a function. Which time interval shows the largest rate of change? From 0 to 2 seconds, which goes from 9 feet to 13 feet in 2 hours. That's 4 feet in 2 seconds, which is 2 feet per second. The next one is 0 to 3 seconds. So that goes from 9 feet to 9 feet. That's no change. The next choice is 4 to 5 seconds. That's from 0 to 8 feet. That's a change of 8 feet per second. And finally, from 6 seconds to 8 seconds goes from 10 feet to 10 feet, which is another no change. That means C is the largest rate of change, a change of 8 feet per second. And our last practice problem, here are the graphs of L of x and R of x. These are in order. So this top one is L of x. This bottom one is R of x. Number 1. What are the values of L of 0 and R of 0? Well, we can see that L of 0 equals this solid point at 1. And we can see that R of 0 has no value. It is undefined because we have an open circle here. What are the values of L of 2 and R of 2? Well, L of 2 equals, we go up and we find right here this solid dot at L of 2 equals 7. And r of 2 is this solid point right here at 1. Number 3. For what x values is L of x equal to 7? L of x is equal to 7 from x equals 2 until x is less than 6. So we could say 2 is less than or equal to x, since it has a solid point, and that's less than 6 because there is an open point. And number 4, for what values is r of x equal to 7? So we see a hollow point here all the way to a solid point here. So that would be 2 is less than x, which is less than or equal to 6. Notice 3 and 4 look very similar. The difference is for number 3, 2 is less than or equal to x because there's a solid point at 2. And on 4, x is less than or equal to 6 because the solid point is down at 6. If you have any questions about piecewise functions or absolute functions, please use class time to ask for clarification before our next test on Monday, February 12th.